Hi everyone, I'm Nilima Rajabat. Here I'm gonna present my project of analysis of algorithms course. My project name is Maximum Subarray Problems. So basically, I have implemented it in Python, and for that I have used PyCharm tool. And like I have used different algorithm like divide and conquer, brute force, dynamic programming. On top of that, I have used Kadane's algorithm, that is efficient version of dynamic programming. Okay, so let's start the code. So for going to the code, I have implemented in Jupyter Notebook. So okay, for opening Jupyter Notebook from PyCharm, I need to give command uh, in PyCharm terminal, that is Python and notebook. So it will open on default browser, and so for saving time, so it will show screen like this, and for saving time, I have already started this application. So okay, so in my project, like I have imported package like random and time random for generating numbers randomly, and time for calculating time complexity. So here I have used different algorithms. So first I've implemented divide and conquer approach. With the help of divide and conquer approach, so basically first it is checking. So in this function I have used this condition for checking base condition, that is if length of array equals to 1, then it will simply return that element. No need to go and run all the code. Yeah. So, okay, so in divide and conquer, it divides the algorithm into two parts. So here, like if I have given assigned the parameter, that is midpoint. This is for dividing algorithm into two parts, and one is left for calculating left sum, and another is for calculating right sum. And then, and after that, I have written another function for like running. So it is for sorting out like if element is greater than current sum is greater than left sum, then it will go left sum would be equals to current sum, and that's the same for right sum. And at the end, it is like adding both the sum, so it will return the value left sum plus right sum. So that's how we are calculating mid sum, like sorry, maximum sum in divide and conquer algorithm. Second, I have implemented brute force algorithm, and brute force algorithm, like it gives all possible solution of the maximum Subarray problem. So here I have defined maximum and then running the loop, and current sum is calculating like like selected array elements in the sum, and maximum is it's like calculating max of like comparing maximum and current sum, and then returning maximum, storing value and then returning. And then I have implemented dynamic programming for maximum Subarray problem. So it is also like here I have given one more variable, that is max ending here. So it's like max ending here, that is initially defined as 0, and then max ending here, it is comparing max of array elements, and then max ending here, and then adding the elements. So it's keep adding the element and then comparing maximum and max ending here. So whichever is maximum, it is storing in maximum and returning. And at the end, I have implemented Kadane's algorithm. So Kadane's algorithm is like I have given another variable, that is max so far. And so max so far, it is like keep continuously adding, it iteratively adding, and then at the end it is returning max so far as maximum of the elements. So for that, I have given input array that is size like 10,000, and it's like running for one time only. And I have run like here for loop for selecting random numbers from -100 to 10,000. So here I have selected total 10,000 numbers, and then when call here I'm calling Kadane's algorithm, so it's giving like maximum, and then it's taking 4.23 milliseconds, and dynamic programming for calculating 10,000 maximum of 10,000 numbers, it's giving 49,000 something, and the total running time here 3.9 milliseconds. And for divide and conquer algorithm, it giving 28 milliseconds. It takes a lot time compared to dynamic programming approaches. And at the end, I have running brute force algorithm. As you know, like brute force algorithm that takes gives all the possible solutions. So it was taking a lot of time for 10,000 values. So here I have reduced the number and used only a few values. It's giving maximum some 347 and in taking time. I think okay. So